relations and functions. So let's look at example 1. Are the tables below a function? Use the one-to-one test to identify this. So let's look at these tables. In order to see if these are functions, every single input, so these numbers that are in this kind of reddish box, pink, have to have one number that they go to in the output. So this is your input, and these are your outputs. So looking at our inputs, the 1 goes to 17. It's going to one number. The 2 goes to 17 also, but it's just going to its own number. It's not going to 17 and another number. 3 is going to one number, 4 is going to one number, and 5 is going to one number. When you see this, this means that it is a function. So we would say yes, that this is a function. Each input is going to one output, the one-to-one test. So looking at the next one, -2 is going to one number, but then we see this 3 is going to 6 and 7. That one number is going to two numbers, so that does not pass our one-to-one test. So we would say, no, this is not a function. All right, looking at the next one, our inputs, -5 is going to one number, -2 is going to one number, -1 is going to one number, 2 has one number, 4 has one number. They're all going to one place, so we would say, yes, this is a function. Okay, looking at the next slide, we have some vocabulary words we need to address first. So domain is the possible values for the x-axis, or the input of the relation or function. Range has to deal with the y-axis. So domain is x and range is y. And then we're also going to talk about the vertical line test. This can help us to identify if a function is a function or not a function when we're looking at a graph. So a test to determine if a graph is a function or not. The vertical line test can only cross the graph at one place at any given time in order for the graph to be a function. So if it crosses one time everywhere, it is a function. If the vertical line test crosses at 2 or more places at any given time, it is not a function. So we're going to use those 3 definitions on the next 9 examples. So let's look at A first. Okay. Also, when we are using domain and range, we are going to be using brackets and parentheses. So let me go back really quick and write this down on your paper. If we have a graph on a point, we will use a bracket. So parentheses with those very sharp corners. If we have a graph with an open circle, or it's going to infinity, so or infinity, we will use parentheses. Okay, so write that somewhere on your paper. If you need to write it below your graphs, you could do that. So let's use that on that first example. So domain has to deal with the x-axis. So I like to use a line to help me see when on the x-axis do I start touching my graph? So I'm going to use a line. You could use your pencil to determine this. Okay, so I like to drag this line across. Oh, maybe not. Okay, so if I drag this line across, I start touching my graph at x is -3 right here. So my domain would start at -3. Now, since I was touching this and that was an actual point that was graphed on my graph, I'm going to use a bracket. So I started when my graph was equal to -3. Then if I continue, I'm touching my graph until, when do I stop touching my graph? On the x-axis. If you see right here, this is the last point that I stop touching my graph. After that, if I continue to drag that line, I stop touching that graph from there on. So my graph goes from -3 all the way to +3. And it was also on the point +3. So I'm equal to, so I'm going to use that bracket of +3. Okay. Now I'm going to do that same thing with my y-axis. So if you want to use a line again, we're going to use a horizontal line this time because we're talking about the y-axis with range. So I'm going to take a horizontal line and I'm going to drag it across my graph. When do I start touching my graph? Down here at -3, I start touching my graph on the y-axis. So my graph was equal to that -3. Then if I keep going and I keep dragging my line, the last possible spot where I stop touching my graph is at +3. So from -3 to +3 is where my graph is between on that y-axis. Okay, then I'm actually going to reuse this vertical line that we used to do our domain. And I'm going to use that to do the vertical line test to determine if this is or is not a function. So if I drag this across, if I touch my graph at 2 spots or more anywhere, this will not be a function. So when I start to drag that line across, I can see already I am hitting my graph here and here in 2 places. So that tells me that this is not a function. All right, let's use those 2 lines again. I'm going to pull them over here, and we're going to use them on our next graph. So I'm going to start with domain. So I'm going to start with my x numbers, and I see right off the bat that I have these arrows on the end of my graph, which means that this graph goes forever and ever. So no matter where I drag this line, this graph is going to continue to go, and I would always be touching it. Even though I can't see that, it continues to go. So that means that this graph goes from -infinity to +infinity. And I said on our definitions that whenever we have infinity, we are going to use parentheses. Okay, let's look at our range. So we're going to use our horizontal line now. And I want to see if I continue to do this, but I I have those arrows again that are going forever. So even if this graph isn't here, I'm going to be touching it somewhere on that line. Even though my line right now is not touching it, if I were to continue graphing that line forever and ever, my horizontal line would be touching this, which means I'm going from negative infinity to positive infinity on my y as well. Okay, then looking at the function, if it's a function or not. We go back to our vertical line, and if I drag this across, is there any spot that I'm crossing in two places? I can see as I drag this across that there's no spot on my graph that I'm crossing at two spots. They're all crossing one time. So this means that it is a function. Okay, let's do the next one. Starting with domain. I'm going to start with my vertical line. So as I drag it across, I want to see the first spot that my graph hits. And I see I have a closed circle right here. So that's where my graph starts on my x-axis. The first x value it's touching is 0. So that means that I am starting at 0, and since it was a closed dot, that means I'm going to use a bracket because my dot was actually there. If it was an open dot, I would use a parentheses. And then if I continue to do this, I can see on the other end I have an arrow, which means that this graph is going forever and ever on the x's. It's going to continue to go on and on and on, which means that this is going to go from 0 to infinity. And I have an infinity, so I'm going to use a parentheses. Okay, let's look at the next one. We got to do range now. So I'm going to move my line, and I want to do my horizontal. So even though right now I see my line is not touching, but I have this arrow, which means if I continue to graph this, my line would be touching it. So whenever we have those arrows, that probably means that we're going forever and ever, or that infinity symbol. So I'm infinity right now, and I would be negative infinity because I'm down here in the negatives of the y-axis. So I'm starting at negative infinity, and let's see where my graph goes to. If I continue to graph or drag this along, I stop touching my graph right here on that 0 for the y-axis. So my graph goes on the y-axis from negative infinity all the way to that 0. And since I was equal to that 0 with that dot, I'm going to put a parentheses. Okay, let's also look at is this a function or not? So I'm looking to see if it's touching in two spaces at any time. And as I drag this across, I only see my graph hitting in one spot no matter where I am. It's not crossing in two places. So that would mean that this is a function. Okay, let's look at example D. Okay, I'm going to start with my vertical line. We could also double up when we're doing this with this vertical line right off the bat and see domain and is it a function. So let's do both of those. Okay, so with my vertical line, I want to see where do I start touching my graph. So if I drag right here is the first time I'm touching my vertical line. So right here at -3. But if you notice, this is an open circle, which means at -3, I'm going to use a parentheses because that open circle shows that I was not equal to the number -3. Then as I continue, I see that the next time the last time I touch my graph is right here. My graph ends with this closed dot at the x value of 1. So my graph went from -3 to a +1, and this closed dot is going to show me I need to be equal to, meaning I need a bracket. Okay? Then we could also look as, is this a function or not with this vertical line test? Is there any point where I'm touching this graph in 2 places? And I can see that no, I'm not. There's only crossing once, which means that this is a function. Okay, now I need to pull out a horizontal line, and remember, you can be using your pencil. So if I'm dragging this horizontal line, okay, I want to see where the first time I touch my graph is, and I see that I'm starting to touch the graph down here at the y value of -4. So my graph is going to start at -4. And I see I have a point here at -4 and this closed circle at -4. So I'm going to use a bracket to say that. And then if I continue to go, I see that I stop hitting my graph right here at the y value of 0. Even though I have an open circle here, I do have a point right here of 0, which means I'm going to need to use a bracket because I did have a point on the graph at that y value of 0. All right, let's keep going. Let's look at domain of the next one. So I'm going to continue to drag my vertical line across the graph, and it looks like I start hitting my graph right here at -1, 2, 3, 4, 5. So at -5, I started to touch my graph, and this was a closed circle. So -5, I'm going to use a bracket. And then I continue to pull that line across my graph, and I see the last time I hit my graph is right here, which looks like it's 1, 2, 3, 4, 5, 6, 7, 8. So at the x value of 8, and this was a closed circle as well, so I'm going to use a bracket again to show that. I can also look, was there any point on this graph where I was touching my graph in 2 spots? And I can see, no, I was touching in 1 spot the entire time, so this would be a function. Okay, let's use that horizontal line to show if we have, what range our range is. So if I pull my horizontal line across my graph, I can see I start touching my graph right here. It's hard to read, so it looks like it's at -9 y value. I start touching my graph, and it was a closed circle, so I'm going to use a bracket again. And I continue to drag this across, and it looks like the last point I stop touching my graph is right here at -2. And it was a point that I was on that graph. It wasn't an open circle, so I'm going to use a bracket again. All right, let's look at the next one. Okay, so for my x-axis, when I'm dragging this across, I can see that these arrows are going down. So it's going to continue. If I continue to graph this, it's going to go on and on forever and ever. And so even though I'm not touching my graph yet right here, if I were to have continued to graph, it would eventually be crossing. So for my x-axis, in both directions, this graph is continuing forever, from -infinity to positive infinity. And I have those infinities, so I'm using a parentheses. I can also do my, is this a function or not? So if I drag this across, am I crossing in two places anywhere or more? No, I'm not. So that tells me that this is a function. Okay? Looking at my horizontal line to find my range, I see that I'm starting to touch my graph right here with arrows, which means that this went on forever. So that means that I went in the negative infinity forever. And then if I continue to drag this line across, I stop hitting my graph right here. And it doesn't have arrows, so that means it's stopping at positive 10, and it had points there that were not open circles, so I'm going to use a bracket. All right, last three examples for domain and range. Let's use our vertical line first. Okay, so for domain, I can see if I'm dragging this line across my graph, I have arrows going in both directions, meaning that my graph on the x values is going forever and ever, both directions. So I'm going from negative infinity to positive infinity. I can also see that when I drug this line across, at no spot was I hitting in two places or more. So I would say that this is a function. Okay, now I need my horizontal line for range. So if I drag my horizontal line, I want to know when I'm going to start touching my graph. And I start touching it on the line. So this is the only number, the only y value that my graph is equal to is -3. So I would just say -3 with brackets on both sides because that's the only number my y's are equal to. Okay, let's do h. Oh no. Okay, let's start with our domain with our vertical line. And when I drag it across, I see that right here is the only place that I'm touching my graph at +3. So for my domain, just like on my range of this one, this is the only number on my x values that I'm touching. So the only number my x's are equal to is +3. I can also see that with this line, I'm touching in way more than two places on my vertical line test. So this is not a function. Okay, let's switch to our horizontal line so we can tell if this is what the range is. I can see that for my y's, that these arrows are going on and on forever in both directions. So that tells me that I'm going from negative infinity to positive infinity. Okay, last example. Our domain, let's use our vertical line. And I want to look, I start touching an arrow, which that means that I am starting at negative infinity. And then when I continue to drag my line across this, I end by touching an arrow, which means it's going on forever. So I'm ending at positive infinity. I can also see when I was dragging this line across that in no place was I hitting my graph in more than one spot. So I would say that yes, this is a function. Okay, then my range with my horizontal line. If I drag this across, the first place I start hitting is right here, which looks like it's the y value of -3. And I'm touching that with no open circles, so I'm going to use a bracket. Then when I continue to drag that line across, I can see that the last time that I touch my graph is when I'm touching arrows, which means